All right. Hi, my name is Todd Voshell. I'm an architect here at Voshell Architecture, commonly known as Vosh. So Heartland Housing Project is a 4-story, 86 unit affordable housing complex that we were involved in here in Fort Saskatchewan, and it consists of 1, 2, and 3 bedroom units. One of the things that the client had tasked me with was how to come up with an innovative design that somehow lowered the costs of construction. So one of the things that was trending at that time, and that I went down that path, and I really promoted it, was the use of shipping containers as a way of modular housing. Shipping containers are very, very interesting modules in that they can be 9'6" to 10'6" high, 8'6" wide, and then a series of them. I took a chance and I put together a presentation for them, and I presented shipping containers as the method of building. Shipping containers at that point in time were kind of how do you put it? Were a very, very unique idea. If you really get into it and you really look at how modulars are built, how modular housing is built, it's kind of built on an assembly line. And so essentially, you could take a shipping container, start it at one end of the building, and outfit it, retro it, the whole 9 yards. And by the time it reaches the end of the assembly line, you could have a built module. This project actually is unique. It's probably one of the more simple projects in form, because it's just a couple of boxes put together. But the technology that went into creating it actually is where it actually went left when other projects go right. It is a very, very unique project. It's the only project net zero energy this far north in the in North America. It uses a number of new technologies, like in insulation. Insulative value of the walls are 45, 46, and we managed to do that within using conventional building methods, right? So we don't have a very thick wall. We have 6 inches wood stud, and then we have 3 inches of rigid insulation proud, which is a typical way of building out here. And then that protects the envelope and actually pushes the vapor barrier as well as your dew point outside of the envelope, and it's located. If this is for architecture students, they'll geek out that the dew point was actually in the middle of the 3 inches of insulation, because we used this insulation that was out of Europe, had a high R value per inch. We were able to achieve quite high R values in the envelope. So we focused on the envelope. The size of the windows were actually taken into consideration. And then we actually used heat recovery ventilation in each unit. What makes this project different than other projects that we've designed? And that is the number of problems that come up. They're not problems that keep you awake at night. They're just very, very interesting problems. They're all like a math problem. You set out with the facts, the numbers, and then you set out trying to show your math. We've all been asked in school, show your math, show your math, show your math. In this case, showing your math is a way of breaking down the problem into distinct facts and then solving those facts and then putting them back together in a built form. Are the electrics sustainable that we use? Yes. That's almost goes without saying anymore. Our building codes and our electrical codes and our stuff like that require us to use LED lighting. But in this case, in normal buildings, they use boilers, they use other efficiencies. They do not view electric heat as efficient because it takes so much energy to create energy, rivers and stuff like that. So, but in this case, where we have solar, we're using something that's already provided. We're gathering that energy, and then we're using it to heat the building. So because our R values in our walls and our roof were so high and our envelope was so simple and specific and had such high R values, we were able to keep our heating energy to a minimum. So each room probably has I think if I remember correctly, a 24 or 30 inch baseboard heat, and that's it for that room. So we were able to minimize the amount of heating required, and because our R values in the walls, in keeping with that, were so high, we don't need air conditioning in the facility. Normally you would because of air leakage. That leads me to my next thing. One of the things that we did do is, because we're controlling air in and air out, it's especially on a project like this, you have to understand all of your parameters. And HRV, which means we were doing heat recovery ventilation. We were recovering heat back from any of the sinks or any of our wastewater. We had them wrapped in copper, and that energy was captured. We do everything and these are all things that we did, not necessarily little tricks, but these are things that we did to try and get the heat back. Instead of sending it down into the sewer or down to a drain or wherever, leaving the building, we tried to capture that energy back and reuse it within the building, which you would kind of go and shrink your eyes and go, yeah, okay, right. But let me tell you, one of the things that we had to do at the very beginning of the building is we had to understand how much energy this facility was going to use. And then we had to design a solar system to support that. So one equals the other, right? With plus 10, 15% on the solar side, just to make up for any nuances. But if you can get the electrical usage in the building down through LED lighting, through all of these things, what was one of the other ones? Our hallway lighting, which is a constant from 10 or 11 o'clock at night till 7 or 6 in the morning, would actually dim. Not that the dimmers were more expensive, they weren't, they were simply off the shelf. But essentially, instead of having every light, we went one every 2 or 3 lights, and we created that minimum exiting requirement. If there was ever an alarm or anything like that, the lights would come back on, and all that was automated. So we tried to be as efficient as possible. We did use sea cans on the main floor. It worked out very well. You would never, the sin of the project is that we did use them, but by the time you're done, you'd never know you were in them, right? You just have these modules, and no different than apartments, really. So this was a unique project. It was a passion project for me. So I was the one person that started with the project and kind of followed it through. Not saying that that's not normal. It is normal. But I had to stay more involved in this project than I would normally on normal projects. Normally, I would get it to a point, or I would work with a team in the office here and get it to a point, and then I would fade off and they would keep going. In this case, I had to kind of follow along, all the way along. So, did I need support from other people in the office? Absolutely. Did we have to really sharpen our pencils and understand how the building parts went together? We absolutely did. Was that all me? Absolutely not. It was absolutely, it did require a lot of it did touch almost every person in the office, from interiors to everything. And even they had to understand the sustainability and what we were doing in order for it to work well. Start to finish, it was about two and a half years. It was a very cost-effective project. That's one thing I want to stress. It sounds expensive. It was not an expensive building. When you break down all of the parts and understand how they go together and are able to convey that information in a black and white way, drawings, and the contractor gets on board, it can become a very efficient project, and financially not one that'll break the bank. You could do it tomorrow. But as far as permits and approvals, from 2 months to 3 months to get a building permit, but it did take, we did spend a lot of time on the front end. What I mean by the front end is in schematic and design development, because remember, the building was pretty simple. So the design portion of it was quite simple. Where we spent a bulk of our time was researching and understanding the different methodologies of construction and the materials that we were using. And some of the materials weren't really even introduced into Canada. Our rigid insulation that was outside of the building came out of the States and had been approved for use in the States, but it hadn't been approved, CSA approved in Canada quite yet. But we were able to show that, do the research and show that. So we were able to utilize that insulation in our project. Okay, so we probably spent where we would normally spend 2 months. I mean, that doesn't seem like a long time, but where we would normally spend 2 months in schematic design and design development, we probably had anywhere from 3 to 4 months in schematic design and design development. And then through working drawings, probably another 3 months. So we were, from start to finish, bulk of the work was done here in the office in anywhere from 6 to 7 months. But it was a very good project that showed results every day. So yeah. The biggest thing that I teach my staff is, and I learned this very, very early in my career, and it served me well, is everything you do and touch is designed and thought through. It doesn't have to take forever. It doesn't have to bog you down. It just has to be thought through, so that if it's questioned or if somebody wants to know more about it, you actually can speak to it. So I guess if I was to circle back on the question, ask questions, understand what you're doing, and remember that everything that you do is designed, right from the details to the use of technology. Sometimes the building will tell you it wants to be red. That's okay. But a lot of times, if the building is coming together and its design is coming together and you've done your background research, it will tell you what it wants to be. And it will just fall into place beautifully. If you're struggling with it, and you're fighting the design, that happens all the time. The way I explain that to my staff is it's like a math problem. Some people are really good at sitting down and fighting through it. Other people, let's say 90%, I'm one of them, leave the math problem alone. And sometime soon, hopefully, you'll be driving along and the back part of your brain has been working on the problem all along. That's where, you get woken up at 3 o'clock in the morning. I got it. Boom. Then you go in the next day and it's not right. But essentially, you're moving forward. So, A is define your problems. Don't get frustrated and let them kind of work themselves out. Work on other things.